10 animals who amputate body parts for survival. In the grand tapestry of existence, nature exhibits a relentless struggle for survival, a relentless battle painted in the crimson hues of tooth and claw. Within this unforgiving realm, the quest to propagate one's genetic legacy becomes a ruthless endeavor, set against a backdrop teeming with countless organisms, all vying for sustenance or reproductive supremacy. This unrelenting competition has forged remarkable adaptations, sculpted by the hands of evolution across the annals of time. Perhaps among the most audacious strategies employed by creatures is the act of self-amputation, a phenomenon known to biologists as autotomy. This may appear as an extreme measure, yet under certain circumstances, it bestows distinct advantages in the eternal struggle for survival. Astonishingly, even humans ensnared in dire circumstances have resorted to severing parts of their own bodies when faced with a choice between life and imminent demise. Herein, we unveil a roster of 10 remarkable denizens of the animal kingdom, each willing to relinquish a fragment of themselves, whether by design or coercion, in the relentless pursuit of survival. Number 10. Lizard tails. In the event that you've ever seized a lizard by its tail, you might have encountered an unexpected surprise. You're left holding nothing more than a wriggling appendage while the rest of the reptile scampers away to safety. For a lizard, shedding its tail is no trifling matter. Tails serve as vital tools for mobility, balance, and as reservoirs of energy to tap into during lean times. So, the question arises, why and how do lizards willingly part ways with their tails? The tail is undoubtedly a boon for lizards, yet paradoxically, it also poses a perilous vulnerability. It offers predators an easily seized handle. To counter this threat, lizards have developed a remarkable survival strategy: self-amputation of the tail. By willingly sacrificing this appendage, they achieve dual objectives: escape from the clutches of their adversary and sow confusion in their pursuers' ranks. The trick lies in the tail's ability to keep moving even after detachment, leaving the assailant baffled. Lizards, in their evolutionary journey, have honed a repertoire of adaptations to facilitate this tail-dropping maneuver while ensuring the appendage remains securely attached. They possess fracture lines in their spinal structure, allowing for clean separation. Microscopic structures play a pivotal role in keeping the tail firmly in place until the precise moment of release. Fortunately, once the tail is relinquished, lizards have another ace up their sleeve: the remarkable ability to regenerate what was lost. This affords them the chance to live another day in the unforgiving realm of survival. Number 9. Sea cucumber evisceration. While losing a tail is certainly a notable case of self-amputation, the crown for the most astonishing act of self-sacrifice may well belong to sea cucumbers. Under specific circumstances, they engage in a dramatic feat known as evisceration, a term that aptly conveys the gravity of the act. When faced with imminent danger, sea cucumbers exhibit a startling ability: they expel their internal organs. Some might describe this process as the rather graphic act of shooting one's guts out of their hind end. Sea cucumbers, though relatively simple organisms, spend the majority of their lives meandering across the ocean floor, devoted to feeding. Lacking a conventional brain, they rely on a circular arrangement of nerves to perform rudimentary functions. Yet, when threatened by predators, a remarkable sequence of transformations unfolds. These changes result in the softening of organ attachments, facilitating their expulsion via the cloaca, a natural orifice. The unfortunate predator is thus met with a barrage of visceral matter, occasionally imbued with toxins and adhesive properties, while the sea cucumber makes its hasty escape. If the sea cucumber successfully evades its aggressor, it possesses the remarkable ability to regenerate all the organs it has cast aside, emerging from the experience none the worse for wear after being effectively gutted. Occasionally, they may even opt to eviscerate themselves in the absence of immediate threats. In cases of parasitic infestations, it proves more convenient to relinquish those infested organs and commence anew from a clean slate. Such is the astonishing world of sea cucumbers and their extraordinary survival strategies. Number 8. Mating spiders. In the world of spiders, the act of mating is a perilous endeavor, particularly for males. After the intimate encounter, several species of female spiders have gained notoriety for a rather gruesome postcoital twist. They turn on their erstwhile mates and consume them. At first glance, this may appear to be a gruesome outcome, but from an evolutionary perspective, it holds a certain logic. Once the male has dutifully passed on his genetic legacy, his biological mission is effectively accomplished, and the female gains access to valuable nutrients essential for her egg production. Yet, a curious question arises: how does the deceased male ensure that no opportunistic suitors come along to mate with the female once he's departed, rendering his self-sacrifice in vain? The ingenious answer lies in the concept of copulatory plugs. Following the mating ritual, keen observers have noted that the female spider's reproductive organs often become obstructed. This blocking occurs as a result of a fluid that males, and occasionally females themselves, introduce into the female's reproductive opening. This fluid subsequently solidifies into a plug, serving as a formidable barrier to prevent other males from depositing their sperm within. However, at times, this defense goes beyond mere fluid. In certain instances, males go to extraordinary lengths, literally chewing off their own pedipalps, structures akin to genitalia, which then serve as a mechanical obstruction within the female's reproductive tract. This, in essence, acts as a literal CCK block, ensuring that subsequent male suitors are thwarted in their attempts to successfully mate with the female. In the intricate world of arachnid reproduction, these copulatory plugs represent a fascinating adaptation, safeguarding the genetic legacy of the original male while offering a unique glimpse into the complexities of spider behavior and evolutionary strategies. Number 7. Spiny mice skin. For numerous decades, mice have stood as the unsung heroes of scientific research. Their rapid reproduction, shared genetic traits with humans, and manageable demeanor have rendered them indispensable in laboratories worldwide. However, it's essential to note that not all mice fall under this umbrella of docility. Enter the spiny mouse hailing from the plains of Kenya, a creature that does not take kindly to rough handling. Should you attempt to lift one, you might find yourself grasping nothing more than a tuft of fur and the delicate skin beneath. The spiny mouse possesses a remarkably delicate dermal layer, prone to fracturing at the slightest provocation. When confronted by a predator, they can strategically shed substantial portions of their skin, effecting a daring escape. Astonishingly, they can jettison up to 60% of the skin on their backs in a single dramatic exodus. Most astounding of all is their ability to emerge from this ordeal relatively unscathed. In contrast, were a human or I to undergo a similar loss of skin, we would face, at best, months of agonizing convalescence, with the looming specter of life-threatening infections. The spiny mouse, in its unparalleled resilience, possesses the extraordinary capacity to regenerate not only its skin but also its fur and even cartilage in a remarkably abbreviated time frame. By scrutinizing these unique creatures, scientists are poised to unlock vital insights into the realm of skin regeneration in humans. The key, however, lies in handling these spiny mice with the utmost care, for in their fragile skin lies the promise of groundbreaking discoveries in the realm of medical science. Number 6. Rodent tails. Despite their stark differences in appearance, rodents and lizards share a surprising similarity when it comes to their tails. These seemingly disparate creatures employ their tails for similar purposes and resort to tail loss for identical reasons. While many rodents possess relatively robust tails, it's a common practice for individuals handling them to grasp them by their tails, as it's a convenient means of restraint and serves to prevent potential bites. However, some rodents interpret this tail handling as a threat and opt for an escape strategy involving the voluntary amputation of a portion of their tails. It's important to note that rodents don't opt for complete tail amputation. Instead, they engage in a rather grisly act known as degloving, which involves the shedding of the skin covering their tails. This results in the vertebrae and muscular structures of the tail remaining intact within the rodent's body, while the predator is left with nothing more than a mouthful of skin. One species, the cotton rat, has elevated this maneuver to an art form. When seized by the tail, the cotton rat executes a graceful spin, facilitating the loosening of the connections between the skin and the rest of the tail before detachment occurs. This astonishing adaptation represents a remarkable convergence in the strategies employed by rodents and lizards when confronted with the need for tail loss as a means of survival. Number 5. Insect limbs. The leaf-footed cactus bug, a relatively inconspicuous inhabitant of North and Central America, finds its existence deeply entwined with the prickly pear cactus. Although often escaping the notice of most people, these insects lead lives that are nothing short of captivating and, in some instances, rather gruesome. Among the male leaf-footed cactus bugs, territorial disputes unfold on the cactus landscape, with these insects deploying their oversized hind legs as weapons in confrontations with rival males. One would assume that these precious legs are invaluable, making it all the more peculiar that these bugs have the ability to willingly sever them. When an insect loses a limb, the possibility of regeneration exists if the insect is in a developmental stage that includes molting. However, once insects reach adulthood, any lost body part remains permanently gone. One might question the wisdom of voluntarily shedding limbs in such a scenario, but the leaf-footed cactus bug has its reasons. In cases where a leg becomes ensnared, the bug faces a dire choice: sever the trapped limb or face the prospect of starvation. If the limb sustains injury, the bug may bleed to death or fall prey to a debilitating infection. In either scenario, amputation becomes an appealing option. Even when a male loses one of its hind legs in territorial combat, it doesn't depart empty-handed. Post-leg loss, the male's testicles undergo a remarkable transformation, enlarging to produce more sperm. This adaptive strategy enhances its chances of successfully fertilizing a female's eggs in the event of a mating encounter. The leaf-footed cactus bug's life story, though it may appear peculiar and even macabre, unveils a fascinating web of survival mechanisms and reproductive strategies that underscores the complexity of the natural world. Number 4. Scorpion tail and anus. When you conjure an image of a scorpion, it's likely a formidable arachnid armed with menacing pincers and a menacing stinging tail that comes to mind. Surrendering one of its most distinctive features is indeed a radical step for a scorpion, but certain species have evolved the remarkable ability to jettison their tails in moments of peril. Regrettably, in doing so, they also forfeit their anus. In the case of an ananterous scorpion, when the tail is seized, there exist 3 vulnerable points along which it can break free. The severed portion of the tail continues to exhibit motion, mimicking stinging actions in a bid to confound any brave souls who dared to approach the stinger. With its tail abandoned, the scorpion hastily retreats, leaving behind both its tail and a segment of its digestive tract. This represents a significant sacrifice for the scorpion, as without its tail, it can only capture and subdue smaller prey. Moreover, once the tail injury heals, the scorpion loses its ability to defecate. Curiously, these scorpions appear oblivious to the loss of their primary weapon. In encounters with prey, they persistently attempt to deliver a sting, despite the futility of their efforts. Remarkably, they can endure for months in this state, which underscores the calculated gamble of shedding the tail. Post-amputation, these scorpions maintain their capacity to successfully mate, thereby ensuring the propagation of their genetic legacy, despite the sacrifice they've made in relinquishing their tails. Number 3. Bee mating. In the animal kingdom, the pursuit of mating is far from a romantic endeavor. It's a primal quest to ensure the passage of one's genes to the next generation. For male bees, existence revolves almost entirely around this singular purpose. These male bees, aptly named drones, lead rather uneventful lives, spending the majority of their days within the hive, venturing out only to seek a new queen for a chance to mate. And when the opportunity arises, it can trigger a frenzied spectacle as scores of drones converge upon a receptive female. During the bees' mating season, you might witness a spectacle of drones fervently pursuing a queen through the skies. Upon catching up to her, they clasp onto her and insert their endophallus into the female's reproductive tract. In a climactic moment, the drone's entire blood supply surges into the endophallus with such force that it ruptures and breaks off inside the queen, expelling all of its stored sperm. The rupture of the drone's genitalia is sometimes accompanied by an audible pop, discernible even to human ears. The entire lifespan of the drone culminates in this explosive ejaculation, but the affair is fleeting, lasting only a matter of seconds. The drone then disengages from the queen, falling backward in a dramatic finale, succumbing to his immediate demise. Meanwhile, the queen retains the drone's sperm within her body, a precious reserve she will employ to fertilize all the eggs she will lay throughout her lifetime. Number 2. Cephalopod sex arms. Aristotle, writing in the 4th century BC, made a rather intriguing observation about octopuses and their unusual mating behavior. According to his account, these cephalopods possessed a rather extraordinary method of reproduction, involving one of their tentacles functioning as a sort of penis. Aristotle's description, however, contained an inaccuracy. No one appreciates the idea of a tentacle inserted into the female's nostril. Nevertheless, he did hit upon a partially accurate depiction of cephalopod mating, a phenomenon that would remain largely mysterious until the 19th century. In truth, male cephalopods have evolved specialized tentacles known as hectocotyli, which serve as vehicles for transporting sperm to the females. The process may entail inserting the tentacle into the female's reproductive tract, but in some cases, it takes a more dramatic turn. Males literally tear off their sperm-laden tentacle and present it to the female. Among the remarkable cephalopods, known as argonauts, a subgroup that includes the nautilus, a particularly unique method of tentacle amputation has evolved. Instead of merely inserting or handing over the tentacle, these males go a step further and detach it entirely, sending it on a solo mission to swim toward a receptive female for fertilization. This unconventional approach emerged as a consequence of the significant size disparity between male and female argonauts. Given their diminutive stature in comparison to the females, launching their tentacle, akin to a penis-like arm, became a more practical means of reaching their reproductive partners. Number 1. Sea slug decapitation. Decapitation is typically synonymous with fatality for most creatures, as the head houses crucial organs vital for survival. After all, we all require our heads to function properly. However, in the case of a few select species of sea slugs, losing their heads can be an unexpectedly beneficial strategy. A curious incident in a laboratory where sea slugs were being studied brought this phenomenon to light. A keen-eyed researcher noticed that one of the sea slugs had, quite literally, decapitated itself and appeared to be thriving in its headless state. Astonishingly, despite the absence of all major organs, the slug's disembodied head continued to swim about and was even observed feeding, though the destination of the ingested food remained a mystery, given the lack of a digestive tract. Remarkably, even the body that had lost its head displayed signs of mobility. Further examination of these sea slugs unveiled a distinct breaking point just below their heads, allowing for a clean and precise detachment of the body. The prevailing theory behind this remarkable behavior centers on the idea that when a sea slug becomes infested with parasites, it may find it more expedient to regenerate an entirely new body rather than persist with the parasitic burden. These sea slugs possess a unique survival tactic: they can endure for a significant period without a functioning stomach. They achieve this by assimilating the algae they consume into their cells, effectively hijacking the algae's chloroplasts to harness energy from sunlight. This ingenious adaptation enables them to sustain themselves even without a traditional digestive system, allowing them to continue thriving in their headless state.